Hello. We today discuss here methods for determination of molecular weight of polymers. We already explained that molecular weight of polymers is its important property, and many properties of polymers polymer samples are depends on their molecular weight. Therefore, and we already discussed in case of polymers molecules that instead of exact molecular weight, that average molecular weight is determined. There are here two methods are given for determination of molecular weight of polymer samples. First is ultracentrifuge. Ultracentrifuge. In this ultracentrifuge method consists of aluminum centrifuge machine, that is aluminum electrical centrifugal machine. All of you know that hand driven centrifuge machine, which is slow centrifuge machine, but electric centrifuge machine is very fast centrifugation carried out in that machine. That ultracentrifuge method consists of an aluminum rotor, and that one is several several inch in diameter, and that machine rotated at high speed in chamber. That polymer solution being centrifuged is placed in small test tube like glass cell in that moving rotor near the periphery of that cell. There is a glass window is adjusted, and that through that glass window we can measure refractive index of that polymer solution, which is placed inside the cell in that rotor, and we can measure refractive index through that glass window for that solution, a polymer solution, after centrifugation. Then by this method, by ultracentrifuge method, molecular weights ranging from 10 raised to 2 to 10 raised to 6 can be measured. And that ultracentrifuge again consists two methods. Out of that, first one is sedimentation velocity method. Sedimentation velocity method. In this method, centrifuge machine is operated at high speed so as to transport that polymer molecules. If polymer solution is placed, if that one is first dissolved in proper solvent, and that polymer solution is that one is placed in centrifuge machine, electric centrifuge machine, and after centrifugation that polymer molecules transported, first case that polymer molecules transported at the bottom of that test tube or cell, if density of polymer molecules is greater than density of solvent. And second case is that polymer molecules remains at the top if reverse is true. Reverse is true means that density of polymer molecules is less than density of solvent. Then the rate of movement of polymer molecules can be measured by change in refractive index at the boundary region. That means as we carried out centrifugation, that polymer movement of polymer molecules takes place along that test tube, and therefore refractive index along the boundary, along the length of the test tube, refractive index of also changes. And as centrifugation carried out, molecule sedimentation means they settle at the bottom. That molecule settle at the bottom, and therefore a layer is established, a layer is developed, layer of two solutions, that is clear solution at the upper side and dense solution, that is heavy molecules at the bottom side. Then boundary is located by sharp change in refractive index because of movement of polymer molecules, and by measuring that refractive index along the length of the test tube or cell, we can measure that movement of that polymer molecules along the length of the tube. Then when polymer molecules moving through the solution, it will experience a centrifugal force along the bottom of that test tube, that is away from central, away from center is that centrifugal force which act on that polymer molecules, and that force is F dash, which is equal to omega square into R into m. Here R is the distance between boundary and center of that rotation, and m is mass of the polymer molecule, that is m upon Na, that is molecular weight, which is here to be find out. Then since molecule displaces mass of that solvent solutions, when that polymer moves towards the bottom, it will displaces that solvent solution having mass m0, and as molecules displaces the mass of solutions, it will subjected buoyancy force, buoyancy effect. That means which is opposite force. Because of centrifugation, molecule try to go towards bottom of test tube. Because of centrifugation, molecule try to settle towards, move towards bottom of that test tube, and during that movement, that molecule experience an opposite force which is known as buoyancy force, and that buoyancy force which is opposite to that centrifugal force, therefore shown by here negative sign, that F double dash is equal to omega square R into m into mu into rho. Therefore, that net force F1 acting on that molecule is that force, net force is equal to force, centrifugal force minus that opposite force, that is buoyancy force, that is equal to m in bracket 1 minus rho in mu into rho into r omega square. This force will be balanced by frictional resistance of the medium for particular velocity dr by dt, and that frictional resistance is given by F2, which is sigma pi eta into Rs dr by dt. And this frictional force at a specific rotation, that frictional force is equal to the net force towards the bottom of that cell, that their net force F1 and that F2, which is frictional force, that are balanced, that are equal at a specific speed dr by dt. That one is equilibrium situation, and consider that equilibrium situation F1 is equal to F2, that is net force is equal to frictional force. Therefore equate that two solutions we got here by rearranging. We got m upon na in bracket 1 minus mu into rho is equal to sigma pi eta rs in bracket 1 upon r omega square into dr by dt. Here S is a sedimentation constant, which is equal to 1 upon omega square r into dr by dt. Therefore substitute that S in above equation. We got here m upon na by some arrangements, here rearrangements. M upon na is equal to m upon na into in bracket 1 minus mu into rho, which is equal to sigma pi eta rs into sedimentation constant S. Therefore we calculate here by rearranging S is equal to m upon na in bracket 1 minus mu into rho upon sigma pi eta into Rs. That sigma pi eta into Rs is frictional coefficient, which is considered as a F2 dash, and we know diffusion coefficient D is equal to RT upon F. Therefore F is equal to RT upon D. Substitute in above equation. Then we got finally m upon na is equal to SRT upon 1 minus mu into rho into D. That m upon na is nothing but molecular weight of polymer molecule. That can be calculated by this equation by using that value of RT, that RT mu rho, some values may be here constant. If S and D are known, we can calculate molecular weight of that polymer sample. Then next method is next method for polymer molecular weight determination for polymer molecules is Fischometry method. We here in our laboratory for experimental TYBSc practical work also, there is experiment based on this Fischometry method for determination of molecular weight of polymer. We discuss this one tomorrow. Thank you.